So question one says for the stat review, you record the zip code, grade level, and SAT score of a sample of 2,146 seniors across the state. What is the type of each variable you recorded? So they have the three bolded, so zip code, grade level, and SAT score. So remember we have categorical, which means everything can fall into a category. A lot of times that means that you're given words as answers like yes and no, true and false, red, blue, yellow, June, July, August, those kind of things. And then quantitative are usually numbers, but numbers could also be categories. So if the number is a category, and like if you think about adding it up and getting a mean, and the mean doesn't really make any sense, then that would actually be categorical. So that's where zip code falls in. So zip code is actually the tricky one. So zip code, because like Dover's is 19901 and Camden is 19934, those don't really have anything to do with each other. So there's just really you're falling into the category of where you live. If you live in Dover or Camden or Wyoming or wherever else you live, the zip code actually is the category. So this is categorical. And if I'm writing stuff today, sorry if that's messy because I only have my mouse. So that's categorical. It's zip code. Grade level sounds like it also would be, if you're thinking like 9th, 10th, 11th, 12th, sounds like numbers, but let's think more about like freshmen, sophomore, junior, seniors. So that also would be categorical. So even if they said I'm in ninth grade and it's a number, it's still categorical because you're falling into like that freshman, sophomore, junior, senior year. And then SAT score, that definitely would be quantitative. It's the number that you're given. If we add them all up and divide, to find the mean, that would show us how we compare to other schools. So the mean would make sense, would be like a valuable number. So that would be quantitative. All right, so then number two, you're looking at this bar chart and you're getting to pick which ones of these are true, and you can select all that applies. So that means it's most likely more than one. So we look here, we see favorite colors, we see percentage on the side, which means that these should all add up to 100 because it's percentage. We could also have frequency on the side, but we don't have percentage here. So question A, most people do not prefer the color pink. So here is pink. Pink is at 15%. So that means that only 15% of people prefer pink. That means everybody else doesn't prefer pink, which is 85%, which is more than half. So most people do not prefer pink, which is true. Letter B, twice as many people favor the color blue compared to the color orange. So if we look at blue, blue is all the way up here at 25%. Orange is down here, somewhere in the middle of 10 and 15%. 10 in the middle of 10 and 15% would be 12.5. If we double that, we would get 25. So that is true. It is twice as many people that favor the color blue compared to the color orange. Letter C, the y-axis, that's the one that's going up here, is not scaled correctly. So I start at 0 and I go up by 5, 10, 15, 20, 25. So I'm starting at 0 and then I go up by the same number every time. So that means it is scaled correctly. So that is not true. And then there are about 125 people surveyed. Well, this is percentage wise. So I don't know how many people are surveyed. It doesn't tell me up here how many people are surveyed. So that might be true, but I can't guarantee it's true, so I'm not going to pick it. So if this was frequency, I would be able to figure that out by adding up all of these, but because it's percentage, I have no idea how many people actually took the survey. I just know percentage wise. All right, let's go on to number three. So number 3 and 4 are both dealing with this histogram. They're telling us here that there's 49 people that were at the speaker session, and they asked how many money each person had on them, and then they recorded their responses, and this is what the response was. So it says, what is about the percentage of audience members with less than $10 in their possession? So we're going to look here. So here is $10. We want less than $10. We know that 10 actually falls into this bar. So 10 to 19 is 0.99 would fall into this bar. So less than 10 is this whole bar here that's representing the histogram. So we can go all the way up to here. And it's somewhere between 15 and 20. And this is the amount of students. So I can't have like 0.5%. Like the other one was percentage. So I could have a 0.5%. This one would have to be a whole number. because I can't have 17.5 students, so that's why they say about. So I would say about 18% would be with that one. Because it is a little bit more than halfway between 15 and 20. All right, and then question 4, obviously, what we've been doing this whole time, what is the shape, the center, in this case, the median they're asking specifically, and the spread. So the shape here, we see the shape kind of roughly goes like this. We have a quick peak right here, and then we have a tail to the right. So then we would say skewed right. Right. The median, so that's the middle number. So that's where it's really helpful that they told us up here that there were 49 people that were at the session, because now we can just cut that 49 in half. Well, first, can we split 49 people into 2 equal teams? We can't. So we have to take one. They have to sit out. So when I'm looking at the median, I'm going to have the middle person sit out. So that's 48 people. So I need 24 people on this team, the one guy or girl that's sitting out, and then 24 people on this team. So I need to find that 25th person. They're going to be my median. So we already know that this bar was 18. This bar is right above 15, so this bar would be 16. If I added those two together, that would give me 34. So that means that somewhere in this bar is that 25th person. Now I don't know where in the bar, so I'm just going to say between 10 and 20. That's the amount of money that is our median. So between, and hopefully you can understand what I'm writing there because I'm writing it with my mouse, between $10 and $20. And that's all we can say if we're not given the data. If you're actually given the data of the 19 people, then you need to find the median. But we're not, we're just given histogram, so we're just doing a rough estimate. And then what is the spread? Again, we're just doing a rough estimate because we don't know if that last person was actually all the way at 59.99 or not. We're going to assume that they're all the way close to that. And even though 60 really is on the next bracket, we're still just going to use that as it. So we're going to say 60 minus 0. So it's 60 minus 0, our highest minus our lowest, which would be $60. If you want to be exact in 59.99, but we're not going to be that exact on the quiz. And then is the mean less than or greater than the median? So this is where we need to understand what mean and median mean. So remember, median is that middle number, and we said it was somewhere in this bar here. Mean is the balance point. So remember we talked about, at least in my class, about the balancing a coin, balancing a rule, I mean. So this would be our mean. So if we only had these two bars, the mean would be here a little bit on this side, so that way it would balance. Like if we were trying to balance these two piles on like a little balance beam, this is where we would need to put the ball that's getting balanced on it. All right, so it'd be a little bit higher than that. So the median would still be someplace over here. Actually, no, the median would be on this side now if we did it that way. So the mean and median would line up. But now that once I start adding these more bars and more bars, that drags the mean down here low, further and further and further. But the median we already know is here. So the more of a tail we have, the mean is going to get pulled down because it's not resistant to outliers. And since this is skewed to the right, the mean's going to get pulled down towards a higher number and look like our audience is richer than they actually are. And so our median would be a better measure of center because it is resistant to outliers. So in this case, our mean would be higher. All right, and if they ask us why, would be higher because we have a skewed right distribution and mean is not resistant to outliers. All right, and then the last kind of short answer one is number 5. They give you these two dot plots, and they say what percentage of each school read more than 3 hours. So we need to make sure that we're looking where 3 hours are. So we read this, here is where 3 hours are, but they said more than 3 hours, so I care about everything above this line. So in here, I have 1, 2, 3. dots, and then 4, 5, 6, 7, 8, 9, 10. So it's 3 out of 10. When I put that in my calculator and multiply by 100, I get 30%. And then this one, I have 1, 2, 3, 4, 5 that are over here out of, again, 10. On the quiz, I just want you to make sure that you double check your dots because they do not have the same number like they did here. Both of these had 10 dots for school A and school B. The one on the quiz does not have the same number of dots, so make sure you double check that. But 5 out of 10 is 0.5. When I multiply by 100, it's 50%. And so those are two percentages for each school. Number 6 and 7 are going to be on separate videos. So if you need help with 6 and 7, go to those videos.